Good morning, and thank you for joining us for a live talk with Dominique this morning, who is a PhD student at the University of Southampton with a working background in coastal engineering, which you'll hear more about in a moment. It's great to see many of you joining us today, and we hope you enjoy the talk. To celebrate British Science Week, Dominique will talk about her role as a coastal detective, including how STEM skills help us all understand coastal change. Please feel free to ask any questions by putting them into the chat, and Dominique will aim to answer as many as she can at the end of her talk. So that's enough from me. I will hand you over to Dominique. Good morning, Dominique.
Hello. Welcome everyone. Thank you so much for coming this morning. I'm going to talk to you about being a coastal detective, and what I mean basically by that is I'm basically trying to figure out what the coasts are doing all the time, and it's a bit of a mix between engineering and science, so we'll talk more about that in a bit. Hopefully you're nice and awake because it's going to be a bit of a whirlwind. We've got lots to cover. So just to start off with, why do we love the coast so much? I feel like a lot of people get very excited about them. Part of the reason is that they're so diverse and dynamic, so they're exciting from a science point of view, but also our culture is very linked to the coast. We're a fish and chip nation, and I think at any one point we're only 72 miles from the coast in the UK, so we're very close to the sea. And I've just got that quote there. It's quite a nice one. On what the sea means to us and how it can affect our feelings. So you guys are all in secondary school, and I was thinking, what did I want to do when I was at secondary school? How can I think on what I really liked then and what I'm doing now? And I was like, oh, well, I really liked fossils. I was a big fan of Mary Anning, 18th century fossil collector. Really liked Pirates of the Caribbean, obviously, and also was a big swimming and snorkeling fan because I used to go snorkeling at my local swimming pool. However, then I also thought I was also interested in loads of other stuff. I really liked art, I really liked music, I liked anything a bit spooky. So I think the point of the talk today is I'm not going to try and convince you to be coastal scientists, but I just really want you to be excited. That's the drill. I just really want you to be excited about things that you find interesting to you, and hopefully this will be a good example of a person that's found something they're interested in and then has gone on to get a career in that area. So what did I do after school? I did school, I did college, I went to university. I actually didn't do very well at university. I didn't really understand what was going on most of the time, so I couldn't get a job when I finished. So I went to work for the RSPB, and so they're a nature conservation charity. I worked there as an intern, and we looked at lots of, we did ecosystem management, so lots of chainsawing and tractor driving, very fun. And from that, I got involved in a project building tern islands, so shingle islands that these birds could nest on. And I really liked the project, and I was like, oh, this is amazing. So I went back to university after that, and I studied coastal engineering because I wanted to know how we built these islands, who decides how big they were, or what they were made of, or where they were put. So I went to study coastal engineering, and that springboarded what I was doing, and has really helped in my career since. You don't have to go to university to end up in coastal science or science or engineering, and I'm not going to go through it, but I've included this map for you to look at later because this talk will be online, and it just shows you a few different ways in which you can end up in a engineering or science role. So I said coastal detectives is a bit of a mix between engineering and science. So I'm just going to explain a few different projects that we're that have been involved in. So to just highlight the difference between the two. The engineering side of things, the definition of civil engineering, which is this coastal is a branch of, is basically anything you see where you're studying, anything that's built by humans is an example of engineering. So you can see in this image we've got a big massive artificial creek network where we've built a It's sort of a recreated marsh. So it was fields and, you know, where they had cows and sheep and stuff. But we wanted to create a new coastal habitat here. So we built a great big wall and excavated these channels so that seawater could come into the site and flood the site to improve the sort of species improve conditions for species that could live there. So that's one example of engineering that we've done. Another is the design of beaches. So that's something I've done quite a lot on the southeast coast. So we've got a picture of Whitstable Tankerton slopes on the right hand side, and you can see these structures called groins, and they essentially control the size of the beach and they slow the movement of shingle. So someone needs to design how big does it need to be, how wide do they need to be, and then we need to build it. So we've got like a little digger down in the bottom left, and the reason that we do that is primarily it's an anti-flooding measure or an anti-erosion measure. So our beaches are actually like the first line of defence in a lot of places in the UK against flooding and erosion. So the top left picture is Whitstable in the 1953 floods. So yeah, you can see really bad flooding, and that was because the sea wall breached. And the way that we manage flooding now is, yes, we've got a great big sea wall, but in front of that sea wall we have a huge beach, and that acts as a secondary layer of protection. And now on to the science. So if I just get this to play, the science side is more kind of understanding what's going on and finding different ways to measure the sort of subtidal and the nearshore, and really understand how the beach is responding to different environmental forces, generally waves and tides, and we'll talk a bit more about that in a bit. So yeah, so in this image we've got my little Pico cat boat, so I drive this around the coast and it actually it maps the sea floor, and it also has a laser scanner on top. So if you look at the top right image, this is an image that I captured when I was in a harbour. So you can see all the boats that I've caught in that scan. Another thing we've been doing, and sort of another example of a science coastal detective application, is using radar. And the radar basically measures it sends out a beam, it measures the reflectance of the radar beam that it sends out, and that gives us like a bit of an image of the coast. It actually helps us image waves, and because waves are predictable, we can then infer things about the seabed, so we can work out the water depth from the speed of the waves. So very sciencey. If there's any physics teachers there, I'm sure they'll be very excited by this. But yeah, that's another sort of application. So we're really trying to understand not only what's going on top of the beach, but also sort of the subtidal part of the beach, so the bit below the water. And the reason for that is that if you imagine like an iceberg, you've got like the very top of the iceberg is exposed, but actually 90% of it is under the water. It's exactly the same with the beaches. So that's the kind of cutting edge science that we're doing at the moment. Here we go. So, and how does that translate into like job work? So here we've got a series of different photos. So we've got on the left-hand side, we've got an erosion study that's being carried out in Hemsby, and that's my colleague Claire driving a quad bike to measure a beach. On the right-hand side, we've got a seawall, so someone had to design that again, kind of linking back to the slides that I've done previously. In the centre, we've got some plant information. We've got some on the right-hand side. There's a flooding map, so you do modelling to predict flooding. And these things all sort of tie into business cases. So the reason I've got a pile of money in the bottom is not because you get loads of money. I mean, you get paid fairly well, but the reason for that is actually that when you get all of these sea defence schemes, like you have to work out like a cost benefit analysis, and you say, okay, I want to build this great big seawall, and I can justify using taxpayer money to pay for that seawall by saying if we don't do any works, all of this flooding and destruction will happen. If we do these works, we'll be saving all this cash. So that's how it sort of ties in like a practical sense. But anyway, back to coasts. So some lovely pictures here of New Zealand, mangrove forests. There's an Iceland, Black Beach in Iceland, and also Vietnam. So just from these images, you can see how different coasts can be. And I've sort of prepared like a quick sort of way to check in, like when you're trying to understand a coast as a coastal detective, your sort of questions are like, what's going on? What's driving this? The evolution of this beach here, and yeah, so the main way to do it is through this nice framework that I've devised. So after this talk, you'll all be coastal detectives, or at least you'll have the means to understand what's going on. So when you look at a new site, first thing you want to do is understand the geological setting of your site. So you want to look at the rocks and the hard stuff. So I always start off by looking regionally. So what's the sinking or rising of the land doing due to isostatic rebound? So you might have done that in geography. It's essentially where the ice sheets during the last glaciation pushed down on the UK, and as they've melted, the weight of them is gone and the land underneath is like pushing back up. So sort of imagine if you were sat on a big mattress, as you get off, the mattress might stay indented for a bit, but after a while it will rise up. It's that kind of thing. So understand what that's doing, because that'll affect what the water line, so the amount of water in the sea will be independent from what the land rise or land fall is doing, and that'll affect how the waves and tides deal with the amount of sediment, because as the land is rising or falling, you'll either have an excess or a deficit of sediment. So you'll either have loads of sediment or not enough sediment. And as we know from the previous slides, when you're using things like beaches as coastal defences, you want as much sediment as possible, really. But that's not always the case. So first look, you stop, you go, what's the big geological picture? Is the land rising? Is the land falling? You want to look at the shape of the coast. Are there any hard rock outcrops or any soft rock outcrops? This is all stuff you'll cover in geography, in GCSE. And then, yeah, you want to know how much sand there is or how much fine sediment. And then the next two steps, which we're going to go through, are really working out, when we've got that sediment, how does it move around? So the next thing, once we understand what all the hard rock sediment stuff is doing, we want to understand what the waves are doing. And the waves are really the primary driving force in terms of coastal change. So waves are formed by the wind blowing on the sea surface, and you get little ripples form, and over time they get bigger and bigger and bigger, turning into huge waves sometimes, especially when we get storms. And the way that these affect the seabed and the beach is that actually, although you see the wave on the surface, it actually extends all the way down the water column. So it starts, if you imagine a wave going like this, I'm not sure if you can see me very well. Imagine it's sort of like orbital motion of the water particles, and those extend right down to the wave base. So it goes down in a conical fashion. In deep water, the wave base doesn't touch the seabed, so it doesn't affect any sediments. But as the waves progress inland, they start interfering with the seabed bottom, and that can move sediment around. So that can cause erosion, and then it's sort of transported along the beach. And that's sort of like the key driver for change in coastal zones. So yes, some places have, so when I was talking about how the waves are formed, when the waves are formed, they're formed by wind blowing. So if you imagine the length of the sort of distance between the nearest bit of land that the wind's blowing over and your sort of end point, if you've got a really long stretch, so for example, on the southwest coast, the wind's typically blowing from the southwest, so from the Atlantic, and the fetch, which is the word we use to describe the amount of time that the waves have to generate, is really long. It's like over 1,000 kilometers. If you think about a little lake, the amount of the distance that the waves can travel or be formed over is going to be much, much smaller. So the waves, the height of the waves and how much they can affect the seabed will be affected by that. So you'll get much bigger waves if you've got a longer fetch, and you'll get much smaller waves when you've got a smaller fetch. And that'll affect the amount of sediment that can be moved. The final sort of thing to take into account is tides, and understanding what the tidal range is. Tides are basically caused by sort of gravity, really. So you've got the Earth as a mass, and you've got the Moon as a mass. And as the Moon moves around the Earth, it actually causes the surface of the Earth's water to sort of bulge towards it. And because all forces balance, we get an equal bulge on the other side of the Earth. And then you also get other effects, but these are generally caused from continents getting in the way. But generally, that's how the water sloshes around the world. And you can see in this bottom left image, we've got the UK, and we've got a tidal map. So those little spidery things, the point in the middle, there's no tide, but then a wave will travel around those sort of spider legs, as it were. And the colours show the sort of tidal range. So where the wave is really steep, it's shown as red. So that's where you get a really big tidal range. So I don't know, 10, 12 meters in the Bristol Channel here. Or in some places you get a small tidal range. And this is really dependent on sort of what the coastline is doing. It's different everywhere. So yeah, and the way that this can affect sediment is that maybe in a place where you don't have so many waves, it becomes important then. It really affects the different kinds of plants that you get, especially if you're in an estuary. If you've got somewhere with a large tidal range, you'll get a whole host of different animals that can live in the different sort of parts of the tidal range. So it gives, having a big tidal range can really affect the sort of species distribution or sort of habitat space that species can colonise. So yeah, so it's a big, and sort of vegetation, it's not a fourth point because generally on the coast we don't have vegetation, but in some places you can. And if I did have a fourth point, I might have one for vegetation, and how is that affecting the evolution of the beach? So yeah, so when you're looking, next time you go to the beach, think, what are the rocks doing? What sediment have we got? Then look around, see what the waves are doing, and then look at the tidal range and think, oh, how big is it? What's it changed? Does it change very much? If you guys are down in Southampton, probably not that much of a tidal range. If you're in the Bristol Channel, it's going to be super high. So it'll be different all the way around the coast. And of course, those tides create currents as with them, which if they're combined with wave currents, can really transport a lot of sediment. So I've sort of flown through that, so we've got some time for questions. I just wanted to plug the Science and Engineering Festival that University of Southampton are running this week. So it's all week this week, and I know that on Saturday they're opening up a lot of the university, and you can come down and I think if you look on the website, if you Google Science and Engineering Festival Southampton, there's loads of stuff there that you can sign up to. I'll be at Boulderwood, which is one of the campuses, and I'll be there with my robot boat, the Pico Cat, so the little yellow boat. So yeah. So yeah, just in summary, we've looked at different routes into coastal science and engineering. We've looked at a couple of different science and engineering projects. And then we did some coastal detective training. So you're all now coastal detectives if you want to be, but also appreciate you might not want to be. So yeah, hopefully that was an interesting and informative talk for you. But yeah, and also if you are interested, when you get the copy of these slides, which I think will be on the recording, there's lots of further resources if this is the kind of stuff you're interested in. So yeah, thank you very much.
Thank you, Dominique. That really was interesting, and it must be so hard to try and fit it all into a 30-minute talk, well, 20-minute talk. We will put the links, we will send the links out post-event. So yeah, well, we haven't got much, we've got 10 minutes, let's go through. So there's lots of questions coming in, so I'm going to hand you over to my colleague Sophie, and she'll put those to you. So thank you, Dominique.
That's great, thank you.
Thank you, Lisa. So the first question I've got come through is, do you know of any apprenticeship routes into your industry?
Yeah, so I've worked at a couple of different places. So I first started out working at the Channel Coastal Observatory in a local council. They have councils all around the UK where you can work, and I know that they tend to hire technicians. And that's sort of like, if you look at a role and you see a technician job, generally they're only asking for GCSEs or A levels, so you can go straight into that. They don't come up that often, but if you find the different places where you can, or if you find somewhere you want to work and then you keep that in mind, you might want to like ask them for work experience, and then sort of once you develop that relationship, they can always email you if a job comes up. And so yeah, so look out for technician positions. That's exactly the same. So I also worked at Jacobs, exactly the same there. They'd have apprenticeship roles, so you can do like an apprenticeship route into engineering, and yeah, working on very similar stuff. So yeah.
Right, that sounds really good. Okay, so I've got a question. How can we prevent coastal erosion for the future?
Good question. So it's very difficult. We can engineer it, basically. We can engineer, we can prevent flooding and erosion by building these big defences and holding the sediment in place. As sea level rise is happening, we actually get bigger waves at the coast. And we're going to be starting to get more or we expect that we'll be getting more storms. So we will expect higher levels of erosion. So we can build the defences bigger, but it's more expensive the bigger the defences are. So there's a point where we're like, should we continue to build bigger and bigger walls? Is that really the right approach, or should we develop an adaptive approach? So what the Environment Agency are really looking at now is in areas where there's not, people aren't particularly living behind the seawall. Maybe there's only a few properties. Maybe it's better to let those areas go back to the sea. A lot of the land in the UK is actually reclaimed, so it used to be part of the sea, and we built big seawalls and drained it. So we might need to make space for water and sort of revert back to a more adaptive approach, and that might mean that we only use the land sort of part of the year. It might be that we let the land flood a little bit, but actually we're building houses that can cope with being flooded. So yeah, I hope that answers your question.
Okay, is there like green infrastructure? Do they use green infrastructure to do that as well? Sorry.
Yeah, no, that's right. So no, green infrastructure is a really interesting area of research, and is being applied to. So green infrastructure is basically, so I was just sort of saying that we can build bigger and bigger beaches and we can build bigger and bigger sea walls, but to make that kind of more sort of environmentally friendly, I mean, not that it's not environmentally friendly, but environmentally enhanced, you can include green structures. So that might, on a sort of eroding riverbank, that might involve like like greening terraces, or it might involve planting of like willows along the riverbank. Coastal zones don't tend to use it because they're more exposed, but there are examples of things that we can do to sort of encourage plant life to grow. So there's a cool project called vertipools and eco rock reefs that are sort of being developed, and that's sort of, it's basically we're building the same things, but we're making little holes in them so fishes and limpets and wiggly stuff can live in them. So yeah,
that sounds really cool. Yeah. Okay. Do I need to be good at science to be a coastal engineer?
So I think that depends. I mean, you don't need, well, my personal view is that if you don't particularly get on with a subject at school, that doesn't necessarily mean that you're not good at it. It might just be that you've not found something that really, really interests you. So I think, you know, like maybe if you're not doing well in tests that much, but actually if you can apply something where you're like, oh, okay, I'm really interested in this, and then you sort of start to break things down and understand it at a more granular level, you can apply yourself to anything really. So it is a science subject, so you know, it helps to be able to be like good at maths and stuff, but it's not a be all and end all. If you're not good at maths or if you're not good at science, like as long as you're sort of passionate and committed, like you'll learn all the different bits. Like it's just to sort of be belligerent and stick at something that you like, and eventually you'll get there. So
okay, yeah, that's good. What do you like most about coastal engineering and science?
ooh. I mean, I do get to go to the beach quite a lot, which is really nice. So yeah, I mean, I like the fact, I think one of the things that I really like and that I've been pushing for in my job is that I'm not in an office all the time, which is really important to me, because, you know, I think it's really great to be in an office with colleagues and doing stuff, but actually I get a lot of value from being out on the beach and like measuring things and like yeah, just not being inside all the time is really lovely. So that's my favourite bit of my job. I don't get to go out that much, but yeah, it's a really nice perk of the job.
So there are some practical aspects to it then. So that's
yeah, absolutely. Yeah.
Okay. So kind of leading on from that, what would you do if you weren't in coastal engineering?
Oh, ooh, and we talk about, so the other PhD students talk about this quite a lot. There's a few that want to be comedians. Someone's really into magic. I'm not sure what I would do. I think, yeah, I mean, I've always really loved music. I think when I was 18, I really wanted to be a music journalist. So maybe I would have gone down the journalism route. I really like writing. I'm dyslexic, so I'm not great at writing. But like I said, if you're not that good at something, if you persevere and like just stick at it, eventually we'll get good at it. So I like to think that I'd be a journalist, but maybe not.
Who knows? Who knows? Okay. So do you get to travel abroad as part of your work?
So initially I didn't. So I was working sort of local, so with like the local council, and then I worked with Jacobs, who generally worked for the Environment Agency. So they were all UK based projects. But since coming to university, because universities are typically like, they're kind of like, they really promote international sort of collaboration. So last year I got to go to Copenhagen, which was really cool. And while I was in Copenhagen in Denmark, we were actually doing a project on Greenland. And if COVID hadn't happened, we were going to go to Greenland. But unfortunately, that sort of like knocked the, sort of got in the way of that project. But I'm hopeful for future work. But yeah, one of the nice things about actually working in a university is actually that you can be like, so and so's doing some really cool research. I'll email them and see what they're doing, and then you can like build relationships and like work together, and it's a really, really nice thing. But yeah,
that does sound lovely. Okay, we've still got a few more questions. What ambitions do you have for the future?
Oh, well, I'd like to keep doing this. So I'm very near the end of my PhD. I've got about 6 months left, so I need to pass that. So it's going to be quite difficult. But I'd really like to stay working in coastal science. I think I'd like to stay in the university, but I think I really like that sort of mix between working in industry where you're doing really practical things. So you're like designing new beaches or sea walls, or like maybe you're writing some policy to like guide what approach should be taken in the future. I really like that, but I also really like the sort of innovative sort of finding out new stuff about our beaches. So I hope, if I can, I'd like to do a little bit of both, so maybe half and half.
Fantastic. Okay, I think we've just got one more question, unless anyone's got any burning questions. I need to get them in quick because we're at 9:10 now. Why is some coast pebbles and some coast sand?
That's a really good question. So a lot of the pebbles that you see in the UK, so you've got those sort of orangey ones, they're sort of siliceous material, so that's flint. And that comes from, you might have seen like big chalk cliffs. I'll try and be quick because I know you've got other lessons to go to. You've got big chalk cliffs. When those were deposited under the sea, because they're small dead animals, they would have been on the seabed for a while. Other animals would have got into the seabed, burrowed around, and then as that became buried and more stuff died, silicates would have been pushed out because of the amount of pressure from the sea above it and the rock itself, and you would have got these lumps of flint form. And what's happened is essentially either from glaciers or from the sea or whatever has eroded all that chalk away, and you've got those big flints. They've then been washed up on the beach, and then because of abrasion and the rocks hitting together, they've broken down into smaller bits. They've oxidized, so they've gone from blue to orange, which is what you see on the beach. And that's why we get pebbles in some places. Sand is basically sort of rock broken down into a granular level. It's generally quartz, but it can be other minerals. So yeah, those are the two sort of different sources. But I could talk about that for a very long time, but you will be very late to your next class. So yeah, good question though. Good coastal detective question.
Thank you for that, Dominique. That was absolutely fantastic. And thank you for everybody who's putting questions into the chat. I'm just going to hand over to my colleague Lisa just to finish off. Thank you.
Thank you, Sophie. Thank you, Dominique. Wow, that really was informative and interesting. I think we need to book you to come on for a whole day to continue talking about it. And we hope that our audience has been inspired to learn more about working in this interesting industry. And maybe we'll have some more coastal detectives in the future. So thank you everyone for joining us today. We're sure that you found that interesting because we did. And yeah, enjoy the rest of British Science Week. Goodbye everyone.
Thanks, bye.